So let's get started by drawing a basic box. You can follow along if you want. Ideally, you would want to follow along. You can pause the video so that you can make that box on your own. Making sure that the lines are parallel. Now, the one thing that we should note here is that this kind of drawing, called an axonometric projection or drawing, this doesn't really represent real life. So you must have heard of isometric drawings, and isometric drawings are a kind of axonometric drawing. They don't represent real life because in real life, everything is in perspective, meaning in a perspective projection, when I draw this box, there will be a part of the box that recedes. So in this case, for the axonometric drawing, the lines are essentially parallel, but in a perspective drawing, there will be some lines that won't be parallel to each other depending on the view that you're using. So we will be tackling perspective drawing in the next section of this course. So for now, in 3D drawing, we'll be starting with axonometric drawings so that you'll be able to grasp the concepts. Now, the concepts in 3D drawing will be applicable to perspective drawing, like what you did in the box slicing drill, in the box with cylinders drill, in the building blocks drill. If you feel confused about all of the lines that you have to make, I'm going to tell you right now, they will be used in perspective drawing. So the quicker you're able to be less confused with all the lines you're making, the better, because we will be doing the same thing in perspective drawing. Okay. So I have now my cube, and for reference, I'm just going to indicate that this two sides, this will be the front side, and this is like the right side of the box, just for clarity purposes. Okay, you don't have to shade things because this is just for the tutorial. In real drawings that you're going to make, this kind of shading to establish things, this would have to happen in your mind, okay, to minimize the number of marks that you're placing on the paper. So what's going to happen? The first thing that we're going to do is we're going to try and find a way around the contour. So in the previous lecture, you know that 3D contours are not the outlines of the 3D volume, but instead the lines that define the form. So in this case, like what you did in the box slicing drill, this is a contour of the box going down the depth axis being this. This is the height axis, and this is the width axis. Okay, very algebra. So, going along the depth axis, this is the contours of this cube. This is the contour going along the width axis. So it can be anywhere here as long as it goes around along the x-axis, and the height axis is essentially this. Okay, so I'm just going to darken these lines to minimize the confusion. Okay, so the first thing that we're going to do is establish vertices. So vertices are essentially points. It can be the corners or any point in this volume. So what I'm going to do is I'm going to take this face or this plane, That's facing this way, so this is the right. And I'm going to place a vertex along this edge. So what I want to do is I want to place this vertex along this edge in the same position. Okay? I want to place this vertex along this edge in the same position. So you might have guessed that in order to do that is I would have to draw a parallel line from this vertex all the way to the other side, making sure that the line is parallel. And that is where I establish now the other vertex. Okay? Let's do that again, this time on this side. If I place a vertex right here, and I want to place this vertex, a copy of this vertex on this edge, same placement, then using parallel projections along this, I would project that parallel line over to the other side, and this intersection is where I'm going to place that vertex. Of course, another way to do that is to measure. So you can always measure this height and then this height so that you can establish where it is. But when you have those parallel edges along for the form, then you could always do the one along the face or the plane. Okay? Now, the next thing that we're going to do is, for this face, I'm going to go back to this face. What I'm going to do is I'm going to place a vertex right here. So this vertex now sits on, nakapatong siya sa plane na to, essentially. And what I want to do is I want to project this vertex over to this plane on the other side. Okay, so how do we do that? One thing that you could do is, and this time I will be using a ruler, you can always go parallel line from the vertex over to the other side. You can do that. However, you're not really sure where the vertex will land in this area. So what are we going to do? We can use contour lines that go around the volume. What does that mean? This vertex sits on this face. So what I'm going to do is I'm going to project a line going up, project a line, continue that line over the top, and I'm going to go down along this face, parallel lines. And since I've already established this parallel line over here, this intersection is exactly where that vertex will be on the other side. So let's try that again. I'm going to be going to this face that's facing this way. So on this face, what I'm going to do is I'm going to place another vertex right there. So one way for you to bring this vertex on this face to the other face is to draw a parallel line over to the other side. You can do that and then do the intersection. Another way you could do that is to go around the form or the volume in two directions. So in this case, I'm going to go this way to this edge, move it around here to this edge right here, and again, parallel line going around the volume. Then I can go across the top to find that intersection there, or I can go across the bottom. I will do this going across the bottom, go down to this edge, parallel line to the other side. And now you can see that it overlaps this. So these are moments when you might get confused. So I'm moving this line over to this point because this is the face where I want to place the vertex. So it goes down, around, and then I'm going to go up. So I have this encircling the cube, this encircling the cube, and now it's this point, this intersection, where that vertex is supposed to be. For the second part, we'll do the same thing. Make another cube. You can again pause the video to make that cube. Or if you're already fast enough, you can just follow along. Parallel lines. And again, I'm going to establish that this is one side facing this way, and we have this other side facing this way. So this is like the front, this is the right, this is the back, and this is the left, and this is the top. Okay, so we will do now that same exercise, but this time in this side, I'm just going to be placing a pattern of vertices. So I'm just going to place one here, another one here, another one here, and another one right here. So right now, it's the same thing. We're going to be doing the same thing. We're going to be projecting these four vertices over to this other side. So for the top, since it sits on an edge, it's just a matter of bringing that parallel line over to the other side. And now you have that first. Then I'm going to take this, bring it to the other side. We are going to, since this vertex apparently is aligned with that, so I can use that, go around, bring that down, and then I'm going to circle encircle a contour line around the back. So parallel line around the back to this edge, and then bring it around the left face. So this now is this exactly opposite this. Let's do now for this third. I'm going to go up top. You can go at the bottom if you want, but the top part is a little more convenient, for me at least. Parallel line across the top, and then bring it down the left face. And then I'm going to bring this around the front to get that intersection. So now I'm hitting the vertex. I'm going to hit two birds with one stone. Bring that to the other side. And then find that parallel line to the other side. This intersection now is the opposite of this. And this vertex is essentially here. So what I essentially did is I have four vertices on this face and four vertices on the other face. What happens is I can actually use these vertices to create some kind of volume, a new volume that I have sliced to create something new. I'm going to use a ruler here to make things a little quicker and clearer. So this didn't really line up. That's okay, as long as you get the principle behind it. So now you have a new volume. So again, you can try this on your own. Try and make a pattern of vertices on one end, project them to the other side, and see what you can create. Now, this can be actually very flexible, because if I, for example, have that same four sets of dots, I'm going to make a very quick cube here. And on this face, I'm going to place those 4 dots again. 1, 2, 3, 4. And assuming that I've done the process of projecting those dots to the other side, this can actually be a curve, so that you can create a curved volume, or something different. I'm going to make a curve. So let's say I can do this. I can curve this around this way, and I can do the same for the other side, that way. And I now have a differently shaped volume for that. And I could just draw a light line around here to indicate that there's this little curve going down right there.